Hello everyone. Welcome to a session on achieving ultra performance on modern enterprise storage with Synology. I'm Jeremy from the UK team, and this is a recording of a session of our online workshops, Synology Solution Day 2020, back in May. So, the agenda for today, we'll be talking about the core part is performance optimization, and we're presenting this as a guide or a methodology, step by step, on how you would achieve this performance optimization. That's going to be really the heart of the session. We'll be illustrating this methodology with 3 mission critical setups: iSCSI virtualization, media editing, and email servers. And then we'll wrap this up by talking about the Synology Enterprise range, which parts of the range will be most suitable for these setups that we'll have mentioned. So, just a bit of a background. Synology, as of 2020, have sold over 7 million servers. You can imagine that's even more users, because often in a business, 10, 50, 100 users will be accessing Synology as a file server. And then to support our customers globally. We're a Taiwanese-based company with our R&D there, but there are subsidiaries throughout the world, in Asia, in America, the UK, France, Germany, to support our global customers. As you know, we come from the desktop world, but in recent years we've been really strengthening our enterprise range with the all-flash arrays that you can see here to give a very complete range, and that is with decades of development in the software which is designed for this hardware to give the best possible level of performance and customer experience. This has been recognized by the media. Notably last year, PC Mag voted us best choice for servers, and on overall scores you can see Synology scoring a 9.2 over some very big names out there. So without further ado, we're going to dive straight into this guide on performance optimization. Now, just a bit of a big picture. You need to consider multiple aspects on the environment and the requirements that you have. Aspects such as the number of bays, the number of users, they're obviously critical. Now, I would say they're fairly obvious, so I'm not going to spend time on them. I'd like to dig a bit deeper into file types and applications, which are very frequently overlooked, but will have a big impact on what you need to put into the storage to achieve the best possible performance at the right possible cost. So, first, small files versus big files. For the same amount of data transferred, very small files will require much more processing by the CPU and will therefore have an impact on performance. So always bear that in mind. And then the type of access, where it's random or more sequential, or random access, will have another impact on the CPU, and also will benefit from having SSDs, whether as in a volume or in a cache. The applications, so linked to random access, what's going to require that? Well, anything around virtualization, databases, whether it's an email server, our cloud station, or Synology Drive Suite, or a chat server. Another aspect is encryption. So encryption does have a bit of a penalty. So I've prepared a bit of data around that. Now all of this is on our all the performance figures are on our website. You can find them there. But generally, what you need to understand, and I've illustrated that by selecting for 5 key business models from a 4-bay rack to a 12-bay, what is the impact of penalty? So for reads, it's 20%. And interestingly, it varies on the model from 2% to 38%. For writes, it's even higher. So remember, encryption has a bigger penalty on the write speeds, and that's on average. It went from 12 to 47%. Now, what was interesting is that on anything that was really under 5 bays, it was really minimal, and sometimes there was no difference at all. So really, I think what that shows is that it's a testament to how well the Synology platform handles encryption, and it's only when you have really large number of bays, much more writing heads with large number of drives, that you can actually start seeing the encryption being a bottleneck. So let's go into the core of this guide. First, we're going to start by drive selection. So here we're not even looking at the Synology itself, but selecting the right hard drives, the right SSDs is really essential. Having ones that are compatible, and making sure that you're making the right choice, because that will have a big impact on cost. Especially with SSDs, it can easily be 3, 4, 5 times the cost of the actual Synology enclosure. I think we're all familiar with the differences between SSDs and hard drives. No moving parts with SSDs means that they're going to be, well, with high performance, more responsive, especially on latency. There is a downside, is that obviously capacity isn't as good generally, and that means that when you're specking out a solution, you need to really have the right criteria to evaluate. And with hard drives, you'll be looking at cost per terabyte, whereas in other deployments where performance is key, you'll be looking at cost per IOPS. So always bear that in mind. You also need to really think of the performance that you actually need. So I'm going to go with a good old car analogy. If you're on the motorway in Germany, you can achieve like a, well, test the top speed of your car. That is going to be more directly related to the throughput of the solution. But there are situations where that's not going to be of interest, like when you're in town or in a small mountain road. There, you care about acceleration and you care about the handling of the car, and that would be, well, pretty much the IOPS and the latency of the storage. So IOPS and latency. What are they exactly? So it's all these little operations coming to the, well, to the CPU and ultimately to the drives. Now think of a supermarket. Your cashiers, your checkout points are your hard drives. Now if you have a single checkout point, well, the customers arrive, and if they all arrive at the same time, well, you can see that there'll be a bit of a queuing happening, and there'll be a wait, and that is going to mean that, well, there'll be increased latency on how long a customer or an operation needs to be handled. Now, what you can already feel here is that maybe you can have, well, cashiers that handle things faster. That would be switching from hard drives to SSDs. Or if you have multiple cashiers, multiple checkout points, so having multiple hard drives will mean that more IOPS will be handled at the same time, and you reduce the queue, you reduce the overall latency on the system. So we said you can switch the type of, well, from hard drive to SSD, or you can also look within the same type of drive, consumer to enterprise. Traditionally, enterprise used to be SAS. Now it's getting a bit more blurred. You can have some really good enterprise drives with still with a SATA interface, so it's not as clear cut. But still, consumer versus enterprise, these differences remain. Now, if you take a look, and we're looking at SSDs here, often you might actually be surprised to see that the IOPS are higher on a consumer SSD than on an enterprise one. That sounds very counterintuitive. Why would you spend more money? So look at the other part of the graph. It's actually not so much the maximum IOPS, but how long can the announced IOPS be sustained over time, and that's where enterprise SSDs really make the difference. They're going to be sustained over long periods of time. So that is what you're paying for. How is this achieved? Well, often it's with aspects such as over provisioning. Long story short, when an SSD fills up, you aren't able to overwrite the blocks of data, and so when you over provision it, you're going to have a better sustained performance. Also, when you have power interruptions, enterprise SSDs have small capacitors, which means that there's a much lower risk of error or losing data at the very least. Now, consumer drives sometimes, and we hear that from customers, well, actually the workloads, even in some enterprise environments, can still be fine. The way the workloads are, they aren't hammering enough to really cause that loss of performance. There's another aspect that you need to, another type of workload to bear in mind, and that's the RAID rebuild. When an SSD fails and you start rebuilding the volume, it really hammers the storage. And again, that is data shared with from some customers. They found that, well, even though their original workload didn't need it for the RAID rebuild, having enterprise SSDs reduced the rebuild by factor 3. So that's really worth bearing in mind, because that's when you're at your most critical. I mentioned SATA, SAS, it's not as clear cut as before. So when would you still need a SAS interface? And we sometimes get that question. I would say really when you're maybe doing hosting and you've got workloads which are really intensive in terms of concurrent read and writes, and a SAS interface can actually handle bidirectional, well, two reads, two writes, a read and write at the same time. And then also the high voltage level, so that just gives better resistance, better error resistance. Now, it does come at a cost. So again, if you don't really need that additional level of capability, you can stick with SATA, and you have a roughly 60 to 70% cost premium for the SAS drive. Now, when you're specking out a solution, and that's worth bearing in mind, sometimes you don't need massive amounts of storage, you just need to have it really fast. So you might be tempted to just go with smaller drives. Now, what this graph is showing you is that the cost per terabyte will tends to not really be optimal on anything under 4 terabytes. And so, if you actually want to have like the optimal capacity, it's currently, I think this was for Seagates I was looking, SATA is at 8 terabytes, the 8 terabyte drives, and for SAS it was 12 and 16. So just bear that in mind, and obviously things change over time, it can be different for other manufacturers. So the idea is really just check the cost per terabyte for the drives you have on the market. You also want to check so TBW is terabytes written, or DWPD, data writes per day. These are actually closely linked. The first one is given just for the entire warranty of the drive. The DWPDs is linked, but well, brought on a on a value per day. I'm going to mention, so data writes per day, you want a value in an enterprise setup of at least one. I really wouldn't recommend going below that. Now, as to, obviously the cost will be higher if you're going for values such as 3, 5, or 10. I would say something like a document server, probably not going to be hammering the SSDs as much. There you can probably stay to a value around 1. Now, if you have something like video editing or virtualization with a very large number of clients editing, or multiple number of VMs, that's where you'll want to go with really, really reliable and strongly built SSDs to withstand the workloads. Right, so we've talked about the theory. Now we're going to start illustrating that, putting it into practice with some common scenarios. And I mentioned we'd have three. The first one is going to be video editing. So think of a small production studio. They've got a few people on their visual effects teams, potentially 5 edit suites. They need 50 terabytes, quite a large amount of hot storage. Those are the live files that need to be editing on a day-to-day basis. But they also need 450 terabytes of archive storage. So when something is no longer being worked on, it still needs to be stored safely. SATA hard drives are generally fine in those environments, especially with 5 edit suites. It won't be too intensive. SATA doesn't mean consumer. Still go with enterprise grade SATA hard drives. Our second scenario will be virtualization, so a developer environment. We've actually got some like live info I'll present in the rest of the presentation, done by our HQ. Generally, when it's virtualization, iSCSI for virtualization, 10 terabytes, 20 terabytes can be enough. It's not generally massive amounts of storage, but here performance is really essential. So we tend to really say go with SAS hard drives, or because SSDs are getting to a very interesting price point, potentially SSDs, but SATA is generally fine. Finally, big databases. A good example is an email server. 1,000 users, so like more of a medium-sized business with 5 million emails per day. Typically, for these deployments, SAS SSDs, so really enterprise SSDs with a SAS interface, are essential. Now, it's not actually that clear cut. You don't have to go with only hard drive, only SSDs, and a good way of moving forward is actually going with hybrid storage. And that's really the way you can will often get incredible performance at a very reasonable cost. When we say hybrid storage, there's really two approaches. Now, if you've got a workload which is very sequential, another one very random, you may actually want to have two separate volumes in the same unit, one for your files and one for your VMs maybe, and the VMs will be on all SSD volume. That can have a slight negative, is that because you have two volumes, therefore two RAIDs, you'll have more overhead due to the redundancy of each RAID. So if you have multiple workloads, but that are all kind of similar, not completely sequential, not completely random, where you can have a single volume for them all, and then one SSD cache which boosts the performance for all of them, and that can really deliver the best possible cost overall. So just think of the type of workloads that you have and choose the best possible type of hybrid storage. So in the case of an SSD cache, the idea is that the Synology system is going to automatically analyze the workloads, the patterns, and it's going to identify what is hot data, files that are constantly, frequently being written and read from the storage, and it's going to keep them on a pool of SSDs, and then anything which is cold data, it keeps them on the hard drives because it doesn't need the same level of performance. We often get the question, when do I need an SSD cache? The answer is sometimes a bit difficult to give, but here are general type of scenarios or workloads which generally benefit from it. A file server, block storage services, especially if you have multiple clients, multiple workstations accessing it, they generally benefit. Virtualization, that's the same, and then anything with a database. So really, an email server I've talked about, an online transaction server, those will benefit from it. And when you have any kind of pattern in your data access, again, that's a pretty safe bet. Now, backup workloads, I always bring these to your attention because even though the backup itself won't benefit, there are other aspects which can see a boost in performance with an SSD cache. So, to explain this, when you've enabled versioning and you want to restore versions, so think of where the versions are written on the file system. The versions happen throughout time, every day, every week, every month, therefore they're going to be scattered all over the file system. The Synology system has got a mapping table to say, well, this version is written on this part of the file system. And when you're trying to restore versions, the faster you get access to that mapping table, the faster it's going to be retrieved. So always bear that in mind. And that is why with an SSD cache, and you have figures here tested by our team in HQ, you can see now this is quite a big database, a million 4K files. We were restoring and rotating the snapshots, but a 3 times performance improvement on the rotating and restoring of the snapshots with an SSD cache. Equally, you want to know when there's no benefit to SSD caching. So when your write or read patterns are completely sequential, think of video streaming, think of surveillance recordings. Again, you're just writing the recording straight to the storage, and you never generally record the same thing over and over again. And then when it's completely random. So that's the other end. There's no pattern, there's no benefit. There's the last aspect you need to think of is that, the storage can have all the SSDs you want, can be as fast as you want. If the rest of the setup is slow, you're going to be wasting your money. So make sure that your workstations of your employees all have an SSD in it to match the speed of the storage, and that there's no bottleneck on the network. So you want to generally have a 10 gig connection. I'll go into that a bit more in detail in the last part of the methodology. So, how much of a boost do you get with an SSD cache? Again, difficult question to answer. So first of all, there are performance figures on the website with all the conditions of the testing for various models. There's also this white paper that I'm going to explain more in detail. So we did this with a unit from our 12 Bay Plus series, so it's got an Atom in it, had 10 WD Red Pros in a RAID 5 and 2 Intel SSDs, SATA based. Here are the iometer settings. You can see with the data size, the SSD cache size, and the workloads chosen for the tests. So here are the results. Really what I want to highlight here, you can find all the details on the website, but basically when we were doing a write or something with 50% reads, 50% writes, we were seeing some pretty impressive boost in performance, at least 2.4 times the level of performance with the cache. Now, when it was only reads, it wasn't quite as impressive, but it was still a 40% boost. So I hope that with those type of settings and configurations, it can give you a good idea of what to expect in terms of SSD cache benefits. Now, configurations. Until now, we haven't actually looked at the Synology interface itself, so now we're going to take a look at all the settings within DSM that you can play with to really optimize the performance of your enterprise storage. The first one is the RAID. There's no getting out of that. You have to create a RAID when you're creating the storage. We often get the question, which is the best RAID for me? Which is the fastest? So we're actually going to nuance that with well, fastest and also kind of the cost. RAID 0 is the fastest, but we eliminate that one from the start because it has no redundancy built into it, so not acceptable for data safety. RAID 10 then comes in at with the best performance. That is because the way it's built, there's no parity being written. It's like groups of RAID 1s. It does come with a negative, I would say, is that because it's multiple RAID 1s, 50% of your storage is being used for redundancy, and therefore you're not benefiting from it. So it can be more expensive, but we see lots of customers who, again, if they're trying to improve IOPS per performance, or if just generally they have really good budgets, often it's the case in the film industry, and NAS is very cost effective, they'll go with RAID 10 to have the best possible performance. If that's not your case, then RAID 5 is probably going to be your friend if you can accept a one disk failure before losing data. And you can see here, RAID 5 to RAID 10, you generally get a 50% boost in performance. RAID 6 is like RAID 5, bit more of a 50% penalty, but it does give 2-disk redundancy. Now, this RAID F1, this is a RAID designed by our Synology engineers for all SSD workloads. So it's very much like RAID 5, but there's a small difference in how it writes to parity. It kind of writes it to the SSD with the lowest life expectancy. Now, why would you want to do that? Basically, SSDs, often you're going to buy them from the same batch, and because they have, compared with hard drives, a much lower life expectancy, when one fails, the chance or the risk that another one fails very closely after is extremely high. So by writing the parity to the same to the SSD, which is most likely to fail first, well, you reduce this risk, and it means that you're more resilient, and you reduce the risk of 2 SSDs failing at the same time. Now, you also have the maximum volume size that you need to keep in mind. So on enterprise units, it's by default standard at 108 terabytes. If you need to go beyond that, so first option is by making sure you have the RAM scaled up to 32 gigs, you can go up to 200 terabytes. Now, you might need to go beyond that, especially for archiving purposes. Well, we've got an app that combines multiple volumes together. It's called Petabyte, and it's has a few limitations. The main one is that, well, it's designed for archiving. So while you have a single shared folder built over multiple volumes, it does have a slight penalty on the speed. So expect 25 to a third of the speeds of a regular volume. Now, if you need to achieve that without the limitations, contact us, and our team in HQ is going to get in touch with you, and we'll work with you on optimizing your workflow and unlocking the maximum volume size up to a petabyte. And in the case of a HA cluster, it's a little bit lower, but still 400 terabyte volumes are available. But again, we'll accompany you, and we'll get our experienced engineers to work with you to make sure we optimize this for you in the best possible manner. Right, so we've looked at the RAID, the maximum volume size. We also need to choose a file system. Now, all Synology units support ext4s because our OS is built on Linux. That's kind of like the key file system for Linux. It also has very low hardware requirements. However, there are some key features, especially for businesses, which are brought with specific file systems of the likes of BTRFS, also known as B-tree file system. Aspects such as cloning, more powerful snapshot replication, and also, I really highlight this for people who do archiving. Think of photographers, people who keep data for long periods of time. BTRFS will, in the background, check the health of your data, will try to self-heal if he finds any data corruption, or if he hasn't been able to, it will send you a notification that there's corruption and that you need to restore from a previous backup. You may have heard that BTRFS may have a slight impact on IOPS due to something called copy on write. That's basically when it's writing, keeps a copy of the metadata. So how does that impact performance and latency? We've actually, again, got all this published on our website to give you the full picture with multiple different types of tests. I'm just going to go very briefly over the topology. So we're using one of our most powerful all-flash arrays. It's got dual CPU, it's over a 10 gig network, multiple clients. Now, just one thing on the setup. So we're doing a iometer test. We disabled RDMA. RDMA can really boost performance, but because most of our users are not enabling it, we want to make these tests as representative as possible. So RDMA disabled. The client configuration, you can see a batch of Intel Core i7s, and we did it with multiple clients doing the tests. So here we have the results for the various tests. You can see 4K, 64K, and then various configurations on sequential, on reads, on writes. And for the various number of LUNs, 8, 16, and 32, comparing ext4 to BTRFS. So overall, you'll find that ext4 does have better performance, but there are actually some where BTRFS is actually faster. So on certain, not all, but on certain, you can actually see a 50% IOPS boost with ext4. And where does BTRFS have the advantage? Well, in general, where there are fewer LUNs, you can see when it's 8, sometimes 16, rarely 32. And it's only on the 64K sequential writes that BTRFS completely betters ext4. Generally, its latency is higher due to the copy on write option that I mentioned. However, bear in mind that can actually be disabled when creating a shared folder. So if you're creating it for an email system, like we're going to show later on, that can be a good option to disable. What are the benefits of BTRFS or of ext4? Well, pure performance, that's random read, writes, and latency. The ext4 has the upper hand, I would say, but again, it's more of a slight upper hand. It's not that BTRFS isn't good at all. BTRFS does bring snapshots on shared folders, very important. Snapshots restoration, not minutes, but a matter of seconds. So again, very interesting. And then self-healing, fast cloning, all this is brought with BTRFS and is not supported by ext4. Right, so we've talked about the file system. At this stage, you'll be wondering, do I need more RAM when you're speccing out your system? Memory is needed when you want the 200 terabyte volume size that we mentioned earlier. If you're setting up a backup system, notably with our Active Backup free software, well, Active Backup, because it does global deduplication, really needs a minimum of 4 gigabytes at the system level, and potentially more if you've got hundreds and hundreds of users. Anything with a database like Active Directory, MailPlus, Synology Drive, that can benefit from memory. So a minimum of 4 gigs. And again, if you have a more specific setup and you want to, well, not overinvest in the RAM, just let us know. Get in touch with us. And the last one is iSCSI pool for virtualization. So I guess technically it's a minimum of 8 gigs, but we tend to recommend, again, for safety, making sure everything's going to be smooth, a minimum of 16 gigabytes. And then really it depends on your LUN size, number of VMs, obviously, the cache size, any snapshots, and potentially higher than that. So let's tie this in with the 3 setups that we talked about earlier. For the video editing, we're going with SATA enterprise hard drives. For the hot data, so that pool, RAID 10 is probably going to be a good choice. BTRFS recommended. And then for the archive, RAID 6 should be good enough. It's less of performance and more optimizing the overall cost. Now, their BTRFS is more than recommended because of the data corruption detection. For these setups with video editing, we find that maxing out the memory generally benefits. So again, it's worth the investment in the RAM. For the virtualization setup, so just one thing to mention, these 3 setups are completely independent. Again, recommendations for each one. The virtualization, iSCSI pool, they're RAID 5 or RAID 10. I would actually probably recommend RAID 5 from the perspective that if you're going to go with hard drives and a cache, the cache is going to remove the bottleneck on the actual volume. ext4 or BTRFS. I would generally tend to still recommend BTRFS for the snapshotting, notably. And then memory upgrade, not necessarily maxing out the RAM, but I think in our setup we went with 32 gigs. We'll detail that later on in the next few slides. Email server, enterprise SSD, SAS based, RAID F1 to reduce the risk of two SSDs failing at the same time. BTRFS essential for the snapshots, and finally maxing out the memory is generally a safe bet with an email server. So for the first one, video editing, we're just going to detail it a bit more, the actual unit that we choose. So the SA3600 is our current flagship in our ultra scalable range. You can see it can be paired with here 4 expansion units, again to deliver that archive storage. It could actually go up to 7 if you needed, so more scalability down the line. I'm not going to really comment on all like the details of the setup. You have them here, but basically we have included all of the costs with the, well, we're going with 8 and 12 terabyte Exos, the scaled up for memory. You can see the performance that you're getting on the hot and cold storage, and at the end. So again, this is an indicative cost for the overall solution. Obviously, compare it with our various B2B or SI partners, but with an indication of an overall cost of £31,000. That means that you have all this storage at £60, just under £60 per terabyte. If you actually look into the hot storage and cold storage, you can see that the hot storage is at £178 per terabyte, but the cold storage, and because there's more of it, is at a very competitive £47 per terabyte. So just to give you an overall picture and how competitive that is with these right configurations. Now the second setup, virtualization. Now for iSCSI storage, and if you only need iSCSI, I highly recommend you go with our dual controller called UC3200. Now the reason is that it has two controllers in an active mode. That means that you get not just better performance, but really lightning fast failovers should a controller fail. We're loading it with 6 terabyte SAS hard drives and 400 gigabyte SAS SSDs for the SSD cache. Now you have to duplicate that setup because there's 2 controllers. Here I've put the RAM at 32 gigs. Look at the performance that you're getting, 137,000 random write IOPS. Now that's an overall cost of the solution. Generally you'll find that with our partners at 8,500, potentially a little bit more. That's £265 per terabyte. So you might think, well, way more expensive than previously. Yes, but remember what you're optimizing here is it's a much smaller pool of storage, but you want optimal performance, and that's a very impressive 6pence, 0.06 pounds per IOPS. Just a word on the configuration. So because you have these 2 controllers, I said you're going to have kind of a duplication. The idea is that you never want to have, especially with multiple clients, too many clients accessing a LUN on a single volume, single controller, and pretty much having the LUN as a bottleneck. So what we recommend doing is 2 volumes minimum, and 1 per controller. So because it's active, each controller is firing at the same time, you're getting the best possible performance. And then on each volume, well, you build multiple LUNs. A minimum of 2 is really what we recommend, but you can go 3, 4, especially with multiple clients, and that means that you're going to get the best possible performance out of the system because you won't be bottlenecking on a single LUN or single volume. Now, what's great is that this test, and obviously we have a lot of developers in HQ, and this is a pure developer environment that they've been running some tests to show us, well, pretty much how the UC3200 is going to perform on a failover. So you can see web services, so this is a kind of a sandbox environment for testing, the code compilation, the log collection services, and they've added, for good measure, an iometer stress test. So we're going to play the video. I really recommend you keep a good eye on the iometer stress test because that'll tell you when the failover is happening and when the control is back up and running again. You can see it's hovering between 50 and 65,000 IOPS. And in a few seconds, we're going to pull out Controller A. So really keep an eye on this, and you'll see the failover. Okay, the failover has started. You can see it here, 2, 3, 4. And as soon as the IOPS come back up here, well, the failover will have been completed. Okay, so here we go. The IOPS are back above 50,000, and that means that our failover is complete and that our system is running again. So again, lightning fast failovers with this UC3200, and that is thanks to the active-active technology and some of our aspects, notably a PCI-based heartbeat. I'll mention those more in detail in a second. Right, so we've done our first two scenarios. We're going to spec out the last one, the email server, a bit more in detail. Remember, 1,000 users, 5 million emails per day. Typically, for setups like that, we really recommend all flash, and therefore it's our FS series flash stations. You don't need to go with the flagship, its little sister. The FS 3400 is just going to be enough. It's got an 8-core Xeon RAM. Scales up to 128 gigs if needed. In our setup here, we've gone with 12 SAS SSDs, and that means that should you need higher performance or more storage, well, you've got 12 bays to leverage later on down the line. You've got a more specific detail, so we went with 32 terabyte UltraStars with a DWPD, so data writes per day of 3, which is a good reliability level. And you can see here, so the cost per terabyte, again, not that impressive, 600 pounds per terabyte, but with an overall solution cost of 21,000, that means that you're on a quite impressive 0.14 pounds per IOPS, and that is really what you need to bear in mind on what you're trying to optimize here. Now, we've talked about what you're putting inside the enclosure, the Synology enclosure, the hard drives, the SSDs. Then we looked at the settings that you need to optimize within the Synology. And as I mentioned, if the rest of your setup isn't going to follow, you'll be wasting your money. So let's take a look at that, and we'll dive into the network side of things. So you have the Synology storage on the left. You want to make sure that any workstations, any VMs, any servers that are accessing the storage are going to be, following the pace. For workstations, think of photographers or people in a design team. You probably want to have 10 gig on your computer. So some have it natively, many don't. But as long as you have a Thunderbolt port or a USB-C adapter, there's really there's some really good cost-effective 10 gig adapters out there which will make it 10 gig ready. Then you want 10 gig or minimum of 10 gig end-to-end. So if you've got lots of designers, you probably want to have a good network, so 10 gig switch in between. If you just happen to have 1 or 2 users, you can just do a direct connection, and that will reduce your overall cost, and it's supported by the Synology, so why not? What you do need to make sure is that you have the right, so I mentioned 10 gig on the workstations or on the servers. You also want it on the Synology NAS itself. There are some cards by Synology, so kind of if you want an all-in-one solution, SFP and Ethernet with single or dual port options are there. You may need to go beyond that. So while we don't have Synology options, there are equivalents by Intel, Emulex, Mellanox. As long as they're on our compatibility list, you can pick from them, and it will allow you to go beyond, I think it's up to 80 gigabyte Ethernet. Now, those projects are not that frequent. So if you feel that there's a card that you'd like to see to use in your deployment, which isn't there, just get in touch with us, and our team in HQ are very responsive. As long as we can source the card, we'll be able to help out on the compatibility. Now, Ethernet or SFP, that's a very good question. How do you choose? Well, from this table, you can see the key aspects. You might be familiar with this. Price and interoperability with your existing system. 10 gig base T or Ethernet is the winner. And then when you need lower power consumption, lower latency, and also making sure that you're able to connect sites that are more than 100 meters apart, SFP Plus clearly wins. Some considerations: security is higher when you're thinking of the risk of a potential fire or just a data tapping. SFP Plus gives security benefits, and also over long distances, well, the transmission reliability is much higher with SFP. So two little scenarios. I don't know, like a campus with an IT department and an R&D department. Both got a Synology, both got a 10 gig switch. How do you connect them? If it's a 300-foot distance, you'll probably be fine with, especially if there's no stacking of your switches, Ethernet will be fine. Now, if you do have a lot of switch stacking, bear in mind risk of interference can be quite high. Power consumption with all these RJ45 cables all over the place, you may want to start using some SFP, and that might reduce this aspect. Right, so I hope this guide or methodology was useful. We tried to illustrate it with some 3 common mission critical setups. Now I'm going to just kind of illustrate which part of the Synology range will be most beneficial. I've kind of highlighted it in the setups, but just to give you a bigger picture, there's really think of it as a 3-pronged approach for enterprise range. There's the all-flash arrays, there's the dual controllers, so the UC3200 and also an SA3200D, which is kind of technically within the 3rd SAS range. SAS being designed for more scalability, but the SA3200D is a bit of a hybrid model that sits on both dual controller and the SAS range. So what are the kind of the highlights of the all-flash series? Now, for the racks, really the idea is having not just ultra performance, but also ultra density, fitting as many possible terabytes in a certain space. Why is that so important? When you put these units in a data center, well, the cost comes at a premium. I think it's a minimum of £20,000 per year for a full loaded rack in a data center. So that means that every cubic centimeter counts. You may not be in a data center or in a server room, and you still need to have all flash storage in the office. You don't want it to drive you crazy with the noise of a rack. There's a desktop equivalent called the FS1018. Our current flagship, so for optimal performance, is the FS6400. You have the key specs here, but you can see the memory scales up to half a terabyte. That's quite impressive. The random iSCSI 4K writes are 240,000. Now, just bear in mind that is for the head units. You can actually use it with expansions, which can take both 2.5 and 3.5 inch drives, which means that you could actually have hybrid storage, all SSD on the head unit, and regular hard drives on the rest. It's quite cost effective with an 0.8 pound per gigabyte solution achievable, and that's really essential in the all-flash solution that you can achieve this with Synology. Now, the SAS series, the idea is here not just uncompromising performance, but allowing it to really scale up massively. You can achieve up to 1,500 terabytes in this range, and one thing I want to mention is that you'll see you might find that the units are pretty much identical. It's just the CPU changing. That's exactly what we wanted. We wanted as much consistency as possible, but we recognized that the CPU is such an important part of the cost of the solution. You may not need the performance of a 12 core, so there are quads and 8 core equivalents in the range. Now, the flagship here is the SA6400. You can see scalability not just on the storage, but on the memory with up to 128 gigs, and also on the network with, as we've mentioned, 10 gig native, but also lots of PCIe cards on our compat list. How scalable is the storage? So the head unit, 12 bays, and as we mentioned earlier, not just 4 but up to 7 expansion units, and that can deliver the 1,500 terabytes at this point in time, when our friends in the hard drive manufacturers bring larger capacities that'll go even further. We're going to finish with the dual controllers. Here the idea is, yes, high performance but with maximum uptime and resilience. So in these units, everything is redundant within a single chassis in a 2U form factor. So that means it's very cost effective, gives you maximum redundancy, notably with our first active IP SAN, the UC3200 I introduced. Some highlights here, the non-transparent bridge, NTB. That means that the heartbeat is no longer Ethernet based, but PCIe based, so ultra fast. And the SATA DOM, that's exclusive to the dual controllers. The DSM operating system is hosted on its own flash memory. That means that if you have a hard drive fail, the RAID rebuild isn't going to impact the performance of the OS. So that's pretty good stuff if you're looking for maximum uptime and availability. The failover performance is quite essential. I've already kind of showed it in the demo, but basically with active and in this IP SAN, it's ultra fast with a maximum, really a maximum in our tests of 30 seconds. And you can see in the case earlier, which was already quite loaded, 12 seconds. Then the SA3200D hybrid storage. This one has active passive for its failover, meaning that it's a little bit slower, but in the grand scheme of things, we haven't seen anything go beyond a minute, which is still ultra fast for most of your scenarios. Now, we've actually had a IT Pro review the UC3200, and interestingly, so they had a big, powerful Dell which was throwing data at it during an iometer test. They didn't even notice the failover. Barely dented the test. That's quite interesting. So, what determines the length of the failover? Because it can seem that it can be barely noticeable up to 12 seconds, worst case scenario 30 seconds. So I've asked the engineers, what really has a big impact is the level of loading. If you're completely like maxing out the unit, that's where you'll be approaching those 30 seconds. So very high loading on the IOPS. Another aspect, all other things being equal, is the detection time and the server retry. So more on the client side. So it's worth optimizing those settings. If you have any questions, get in touch with us and we'll make sure we help you optimize that. Has the volume size got an impact? So I believe that before doing this session, and checking with the engineers, they have not found that the volume size has got a significant impact. So again, that's good info to know. Really, the loading is the key aspect here. Right, so all flash arrays, dual controllers, SAS range for scalability. Those are really our three areas on how we are approaching the enterprise market. Let's finish by talking about our level of support. We recognize that sometimes it's not just about specs and performance, but just for an enterprise customer, if I have a problem, how fast you get it solved. All enterprise units in our range come with a 5-year manufacturer warranty. We have a UK-based RMA and support center. So that means that you're dealing, again, not with a team in Taiwan. You don't have to send the unit back. It's going to be very short lead times on this, and no time zone difference. If you need to go beyond what we offer, we work with partners to provide support contracts. The benefits are, that you have high SLAs, but also enclosure and the hard drives and SSDs that go inside it that are covered, with options for on-site support. Now, in the UK, we have three levels provided by our partner: bronze, silver, gold, with the gold going up to response at time of call, 4-hour response on site with an engineer, weekend, public holidays, all covered. So that all sounds really great. Now maybe you want to try that out, a Synology enterprise unit in your environment, or maybe it's not a case that you are in doubt as an IT admin. You know Synology, but you need to convince maybe your boss, your finance team. Well, bear in mind we have a Synology test and buy program, which since our workshop last year, where it was on the all-flash array, has been expanded to cover pretty much all of the units we talked about today, and the dual controllers and the SAS range. So again, do get in touch with us, and we'll be looking to working with you around the requirements for your projects. I'd like to thank you all for either joining our Synology Solution Day session back in May, or for watching this video. If you have any questions, get in touch with us, and we'll speak to you soon.